Hi everyone. So today we're going to work on multiplying radical expressions. Okay. So basically what we're going to try and do is we're going to try and multiply square roots and cube roots and things. And how do we simplify it? How do we break it down to its simplest form? So kind of like think of breaking it down like we would reduce a fraction. Okay. It's not wrong, but we do want it down to its simplest form, okay? And what we're going for is an exact representation. So no decimals here or anything along that lines. When you talk about the square root of 5, it's the exact representation, and that's what we're going for. So when we multiply radical expressions, the idea here, let's say, is if I take the square root of 2, not the square root of 2, I'm sorry. The square root of 4 and the square root of 25, I can get square root 2 times 5 and get 10. But if I take the square root of 4 and actually do the multiplication, we get the square root of 100, which is also 10. So what's that saying is that if I take two roots and multiply them together, I'm going to get the same answer as if I took the roots individually and then multiplied together. And that's what our property of combining radicals means. That if I have an nth root of a and an nth root of b, and they're real numbers, okay, so no i's, are real numbers, then the nth root of a times the nth root of b is the nth root of a times b. So you can treat them as individuals and then multiply them, or you can multiply them and then take the radical. Key here, though, is that these guys must be the same. Okay, so you can only multiply like radicals. Okay, so we need to say that we can only multiply like radicals. Okay, now when I say radicals, that means, radicals. That means like square roots with square roots, cube roots with cube roots. I cannot multiply a square root with a cube root. That's not going to work. At least not right now. We'll fix that later on. But right now, we just can't. It's not going to fly. All right? Okay, so let's see how this is going to work. So we're going to multiply and then see if we can simplify them. So, square root of 7, square root of 5. They're both square roots. So the way this is going to work is I'm just going to multiply 7 and 5 and keep it underneath the square root sign. Now, if I could take the square root of 35 and get a nice integer answer, we can do that. But we can't, so I'm going to leave it just as the square root of 35. So over here, I have the square root of 6 and the cube root of 6 and the square root of 2. Can't multiply. We would say this is already simplified because I can't multiply the cube root of 6 with the square root of 2. Okay. All right, let's try this. Yes, remember our conversation the other day, you can have negatives underneath an odd root. So I have the fifth root of negative 5 times the fifth root of negative 2. Both are fifths roots, so we can multiply them. So we get the fifth root of 10. And that's as far as we can go. All right, let's try this. They're both fourth roots. Okay, so the fourth root of 60. Now, we don't know how to simplify that yet, and that's what we're going to work on next. Okay, because 35, it's an odd number. That's no big deal. We can break down this radical, but we got to look at their factors and stuff. All right, so we're going to simplify radical expressions, and the way this is going to work is that we're going to break down the factors. So we're going to find factors of the radicand. Now remember, the radicand is the number underneath, where at least one is what I would refer to as a perfect. Now, what do I mean by perfect? If you're doing a square root, I want a perfect square. If I want a cube root, I'm going to look for a perfect cube. Okay. Now the trouble is how do we find the perfect squares and the perfect cubes that are factors of the number underneath? And that's what we're going to work on. Okay. Now, what I do is I use a factor tree to find perfects. Okay, so let's call this find perfect factors. All right, so I use a factor tree to break down the number and to look for the perfect factor, okay, whether it be a perfect square or a perfect cube. Now, here's what the thing is if I'm going for a square root, I want a group of 2, because then now like a 3 times a 3 or a 4 times a 4. So I want a pair. If I'm doing cube root, I'm going to want a group of 3. Okay, if it's a 4th root, we get the idea that I want a group of 4. And I'll show you what I mean when we do a couple of these. Okay, because a group of 3 means the same number 3 times, like 3 times 3 times 3. When I multiply them together, I'm going to get 27, which is a perfect cube. So that's how we kind of develop that perfect factor. All right, so let's start over here. So here's the cube root of 54 and then x to the 5th. So we want to break it down to find a perfect factor and a non-perfect factor. So again, I use factor trees to help myself. So I'm going to take 54, I'm going to break it down, and I'm just going to pick 2 factors of 54. In my brain, that's 9 and 6. And then I'm going to keep breaking them down till I can't break it down anymore. Okay, so 9 goes to 3 and 3, and 6 goes to 3 and 2. Now remember, I'm looking for a cube root. So I need a group of 3 that's exactly the same. So we have a group of 3 3s. So when I multiply them together, I get 27. So I'm going to go cube root of 27. And then this guy, sorry, that's a little too loud. Okay, that's going to stay underneath. We get the cube root of 2. There we go. Okay. So this gives us 3 cube roots of 2 for the 54. All right, so we're not finished because we do have to deal with the x to the 5th. Now let's break down x to the 5th. Now remember, that means 5 x's. Now remember, I'm doing a cube root, which means a group of 3 that are exactly the same. Okay. So here it is. There they are. So that's the cube root of x cubed. And then these 2 are going to stay cube root of x squared. Okay, so let's move this over. Okay. All right. So we did cube root of 27 is 3. There's our cube root of 2. Can't do anything with him. Cube root of x cubed. Well, that's x because that's what number times itself 3 times gave us x cubed. So x, and then this x squared is going to stay underneath. So our answer is 3x cube root of 2x squared. Now, I don't know about you, but I don't want to write out those variables all the time. So we'll see if we can come up with a shortcut. The numbers I can't do much about. Let's come over here. Okay, so we have the square root of 20 x cubed. So I need to look at factors of 20, one of which may be a perfect square. So I'm going to break down 20. And again, I always go on the side here. And I do my little factor tree. And I go 4 and 5. Well, I don't think we have to go much further because we all know that 4 is a perfect square. Okay, so I'm going to leave it as 4. There he is. And then, so I get the square root of 4. Square root of 5. And there's not much I can do about 5. 5's factors are 1 and 5, neither one of which are perfect squares. And then x squared. Well, that means I have, or x cubed, that means I have 3 x's. And I need a group of 2 because I'm looking for a perfect square. So that's x squared. And then I have a square root of x left. Okay, so the square root of 4 is 2. Square square root of x squared is x. Square root of 5x. Now, shortcut. We all know this is a 2. How many times does 2 divide into 3? Well, it's once with 1 left over. Okay, so think of it that way, and it might give you a little bit more, a quicker way to do it. But if you want to write it out, write it out. It's totally up to you. Okay, so we can take this now and take it up a level. One more thing, and we're going to multiply first. Okay, so when you're multiplying, so we're going to take what we just did here. When we multiply, radicals are exactly the same. Okay, same indices. And we're going to multiply the numbers underneath. Okay, so here we're going to multiply our numbers, multiply our variables. Remember, that means add your exponents, and then we're going to break it down. Now you're going to be like, well, why can't we just break it down first? Because, not that that's wrong. I'm not going to say that's wrong. It just, to me, again, this is a personal opinion, if you simplify first and then you multiply, you may have to simplify again. And who wants to do like twice as much work? I don't know about you, but I already do enough work. I don't want to do more than I have to. All right, so let's see if we can do this. Okay, so I have some steps here. Okay, so our first step is that we're going to multiply radicals. So remember, like indices, square roots of square roots, cube roots of cube roots, fourth roots, fourth roots. Okay, so multiply your numbers. Okay, I don't know what 12 times 15 is. Okay, 180. Okay, so we get the square root of 180. Add my exponents. There we go. Okay. All right, so now we're going to find our perfect square factors. So we're going to start with our number. So let's do it here, 180. First thing that comes to me is 10 and 18. Keep going, so 5 and 2. 18 is 9 and 2. Okay, I'm going to stop there because I know 9 is a perfect square. But I also have a pair of 2's, and that's totally okay. So I can break this down. Square root of 9, square root of 4, square root of 5. So you can have multiple factors that are perfects, and that's totally cool. Okay, so I'm going to use my shortcut to break down the variable. So remember, this is a 2. So how many times does 2 go into 6? 3 times. There you go. No more radical. Once you do that little division, that's your answer. Now 2 goes into 5 twice, but it's like 2 times 5. It's 4, but then we want 5. That's 1 left. Square root of y. Okay? So it's whatever goes in evenly comes out. The remainder stays underneath the radical. Okay? All right, so I'm going to take the square root of 9 and the square root of 4. So that's 6. I'm going to bring out the ones that came out. Okay, so I think I'm ahead of the game here. Okay. All right. Use the property of radicals, multiplying radicals. So that's what we're doing. So this becomes 3. Okay, so 3 times 2, x cubed, y squared, square root of 5y. Simplify, so we get 6x cubed y squared, square root of 5y. And there's our answer. Okay, so how do I know we're done? How do I know it's right? Okay, that's a little tougher. But I can tell that I'm done because the number underneath the square root sign doesn't have any factors that are perfects. And the variable, his exponent is smaller than the root. So our root is square root, and the exponent of the y is 1. Okay, so I know that seems like a lot of work, but once you get into a groove with these, they're really, really, like, it's steps. It makes it a little easier. Okay, so let's do this. Okay, and not every problem has variables. All right, so they're both cube. Okay, so we're going to multiply and then see if we can simplify. Cube root of 4 times cube root of 16. Okay, so I'm going to do 16 times 4. I mean, it's 64. Okay, now I'm going to break down. We already know 64 can be 4 and 16. And I can break 16 to 4 and 4. Oh, look at that. It's already a perfect cube. So that's 4. There we go. Now, could I have done this as... No, I can't do the cube root of 4. Cube root of 16. I have a 4th root with a square root. Can't do it. So we're going to say this is simplified. Okay. All right, let's try this one. Okay, they're both cube roots. We're good. We're going to multiply our numbers and then add our exponents of our variables. So 50 times 15, 750. So we get the cube root 750 x squared y cubed z to the 6th. Okay, so on the side here I'm going to do 750. All right, it doesn't matter what two factors you can pick. You can pick the 50 and the 15, which is how we got here in the first place. Break it down. And remember, we're looking for a group of 3 because it's a cube root. All right, now I can see a group of 4. Oh, wait. That's bad math. There we go. Sorry, it's a group of 3. Okay, here's our group of 3. And here, those two are going to get multiplied together. So we get the cube root of 125, cube root of 6. Okay, how do I know it's good? Because 6's factors are 2 and 3. Neither one of those are perfect cubes. Okay, so now I'm going to do my exponent thing. 3 does not go into 5. Or 2, sorry. 3 goes into 3 one time. 3 goes into 6 twice. Okay, so now I'm going to take my perfects, bring them out, write the, I don't want to say non-perfects, but the stuff that cannot be broken down underneath the radical sign. Cube root of 125 is 5. Y, z squared, we pulled those out. And then the cube root, we still have 6x squared underneath our radical. And that's the exact solution. Again, we're looking for the exact solution. No decimals, none of that. Okay, let's do one more. All right, this one looks a little tough. Again, we're doing cube roots. But we're going to have to start out with multiplying the 2 and the negative 3. So that's going to give us negative 6 on the outside. Cube root. Okay, 9 and 12. I want to say that's negative 108. Add my exponents. Okay, so that's what we're going to do here. Now I'm going to take negative 108 on the side, break them down, because remember, I'm using this factor tree to find the perfects. And again, I'm just going to use negative 9 and 12. 9 is negative 3, 3, 3, and 4. Oh, look at that. There's our perfect already. Okay, these 3's. 4 is just 2 and 2, and that's not going to do me any good because I'm looking for a group of 3 for a cubic, not a square. Okay, so I got this negative 6 hanging out. Cube root of negative 27. Cube root of 4. Now I'm going to do my exponents. 3 goes into 3 one time. No more radical. 3 goes into 5 one time, but there's 2 left. Okay. All right, so let's put this all together. Negative 6, negative 3 for the cube root of negative 27, x, y, cube root 4y squared. All right, so this is 18xy cube root 4y squared. All right, guys, let me know if you have any questions. Let's make sure we got all this. Okay, so when you multiply radicals, like radicals, meaning like indexes. Square roots with square roots, cube roots with cube roots, multiply the number underneath. And then we're going to break it down so that we need a factor that's a perfect, whether it be a perfect square or perfect cube. And our variables, remember our shortcut, we're going to just divide the index into the exponent. That's going to give you your perfect. But you can write it out as well. Okay. Simplify all of them. Anybody who's not factors that are perfect, perfect squares or perfect cubes, stays underneath the radical. And remember, how do you know about the variable? Is that the index, the exponent of your variable is smaller than the index. Okay. All right, so let me know if you have any questions. Please stay safe, guys, and I'll talk to you again real soon.